all, welcome to another quick learning. Today we're going back to CodeSignal, working on the Python coding exercises. If you're joining this in the middle of the playlist and you want to see the first video in the Python series from CodeSignal, I'll put a link in the description below so you can do that. Otherwise, I'm going to the arcade, I'm going to Python. And then we're in the section here, drilling the lists. And the last one, 64 prime sum. All right, it is believed that some tribe of South CodeSignal that only two elements determine the person's destiny, the first time he picked a flower and the first time he planted one. They also believe in the power of prime numbers and in the power of sums, and a bunch of other most probably unrelated stuff. So you are wondering if it has something to do with their belief in the destiny determining events. You know that you first picked a flower in year A of the CodeSignal calendar and planted in year B. Now you're curious about the sum of all the prime numbers in the range A to B to see if this number could possibly affect your life. So in this example, A starts at 10, B goes to 20. So the output should be 60 because there are three prime numbers between these two values. There's 11, 13, 17, and 19, and when you sum those up, you get 60. All right, so how will we code this up? So first thing you see is we've got a sum around this. So whatever list we're going to generate from this list comprehension, we're going to sum it up, which makes sense. We're looking at the sum of these prime numbers. So we just have to figure out with our code, what are these prime numbers? So that's what this list comprehension does, is it gives us the prime numbers. So first part here, you can see we're just taking the x and we're doing a for loop here. And we're going from range max A and 2. So I don't know if there's any A's that are less than 2. Here's one. So A is 1. So 1 is not considered a prime number. So the first prime number that could be is 2. So we start with 2. And we want to be inclusive of B. So we also, so in this example, 10 to 20. We also want to include 20 if it's a prime number. That's why we do B plus 1, because if you do the range, it will do up to that number, but not including it. So you have to go 1 over it if you want to include it. All right, so that does that. And then we're doing a filter condition. So this is going to filter it to just the prime numbers to add here with the x. So if not 0 in, so if there's a 0 in this list that's being generated here, that means it's not a prime number, so we're not going to add it to the list. So how do we determine if there's a prime number? So if we've got the x here that we have from here, and we do this percent sign, which is a modulus, which means when you take x divided by this z, is there any remainder? So like if you take, let's do an example. Take 7 modulus 4. That doesn't divide evenly. So you're going to have 3 left over. So if you take 1 4 out of this 7, there's 3 left over. So your remainder would be 3. So this would return 3. Or let's do another example. Let's put in 9 here. So 4 goes into 9 twice, plus there's an extra 1 at the end. So it would divide, you would get 8 from 4 twice, and then there'd be 1 left over to get to 9. All right. That's that. And if we're able to divide any part of this and we get a modulus of 0, that means it's not a prime number. So we're going to iterate over. So the z is going to change from 2. So if something is divisible by 1, it doesn't mean anything because prime numbers are also divisible by 1. Just so you know what a prime number is, it means a number that's only divisible by itself and 1. And then we're going to stop once we hit, so this is just making sure that this becomes an integer. And then x, you can see this 2 stars So 1 star is multiplication, but when you have 2 stars in Python, that means it's taking it to the power. So this is x to the 0.5 or 1/2 power. If you know your math, when you do this, this is actually the square root of a number. So this is the square root of x, and then we're adding 1 to make sure that the square root of x is included in that. All right, so why do we only search up to the square root of x? So let's take 10 for an example. That has a factor of 2 and 5, so this is not a prime number because it has factors other than itself and 1. Once you search and you find that 2 has a modulus of 0, then you've basically already searched 5 because 10 divided by 2 is 5, so it's kind of a flip side of the same coin. So in this case, once you search up to the square root of a number, you're just finding the other factors that are on the flip side of it. So that's why you only have to search up to that. You could search up to x itself if you wanted to, or x minus 1, I guess, because you know, a number is always divisible by itself, but then it's not as efficient of an algorithm. It's going to take longer to run. So that's why we try to limit it as much as we can. All right, so this filters out anything that's not a prime number, and then so everything that's added here in x is a prime number, and then it's just summed up, and then it returns that sum. So if we go ahead and run this, we'll see that that comes out with the correct answer. So hopefully you guys are able to follow along with that, and you'll join me for future videos. Thank you very much.